Now that we've had a chance to look at what a puzzle is and how a puzzle works, we're going to build a couple of puzzle elements that we can use in our levels. Now we're going to be going by that definition of puzzle that we talked about in the previous little video about how a puzzle has objects that are in a given state. The player has mechanics they can use to change the state of those objects. The objects start in a state that is obviously incorrect, and the player must change the state using those limited mechanics to get them into the proper state, which is the victory condition, which kind of solves the puzzle. So to be prepared to create a couple of different types of puzzles, I've went ahead and dropped some objects in the world and kind of made some little adjustments to them. So this is just the armchair from the Edith Finch. This is just a spotlight that I've colored yellow and upped the intensity to make it look visible on the screen. I've dropped a candle in that I'm going to end up adding a light to, so we can do a little candle effect to kind of work there. I dropped in my exploding gnome. It's the same interactable mesh object from our previous lessons, so it's the exact same exploding gnome. If I call interact on it, it'll explode. And then I set up a camera so that I can do a view when my puzzle is complete. I can switch to this view target. So the first puzzle type that we're going to build is one that you've probably seen quite a bit. It's where we take an object. In my case, it's going to be the chair here. We're going to turn on physics. So I'm going to go to my physics and I'm going to say simulate physics. Set that to true. So now my player can push this chair around. Now we're going to make sure that it can accept overlap events. So I'm going to search for collision. It's generate overlap events, so that now when my chair enters a trigger, it's going to register as an overlap. And this way we can push our chair around and try to push it into a trigger that's underneath this light. Now, we're going to have more than one of these, so it's not much of a puzzle when it's just push the yellow chair into the yellow light. It's a little more of a puzzle when we have multiple chairs that are multiple colors with multiple different lights. But we're going to see how easy it is to expand on our puzzles if we build them one piece at a time. So as we work, we're going to think about the idea that our puzzle itself is an object that's in our world. It's not the chair, it's not the light, it's not the triggers. It's this new kind of concept that is our puzzle itself. So I'm going to create a new blueprint of type actor that I'm going to call BP for blueprint again. And I'm going to call this my puzzle manager. And the basic idea is that my puzzle manager, which I'll bring one out into the world, is just kind of this idea or concept of what this puzzle is. And it will handle the puzzle itself that's going to happen. Then the next thing that we're going to need is we're going to have this idea that each of our puzzles are going to have individual pieces. So we talked about that definition of a puzzle is a puzzle has elements to it. If those elements are in the correct state, the puzzle is successfully completed. If they're not in the correct state, the puzzle isn't solved. So I'm going to create also here a new blueprint class. It's also going to be a child of actor, and I'm going to call it my BP puzzle piece. And it's going to represent one piece of my puzzle, one element that solves my puzzle. So if I open up my puzzle piece, there's a couple of things that we need to do in all puzzle pieces, no matter what our puzzle type is. One of those that we're going to need to do is we're going to need a Boolean variable. So let me go to my event graph. I'll go to my variables. We're going to create a Boolean variable for is success. And this Boolean variable, we're going to set it up so that it's true if we're successful, if we've met the objectives of the puzzle. It's false if we have not met the objectives of the puzzle. I'm going to expose it so that we can see it and see what state we want it to be in. And then I'm going to compile so that I can look at my default value. And I'm going to make sure that in my case, by default, my puzzle is not successful. But we're going to make sure that we check that each time we kind of start our puzzle. So that's the general idea of a puzzle piece parent. Every puzzle piece, no matter which type of puzzle we're going to create, is going to have this concept where it's going to check, am I successful? Did I complete the puzzle? Or at least this one piece? Is this piece in the right spot? Is it in the right state? With that in mind, I'm going to open my puzzle manager. And once it's opened, we're going to go to our event graph. And we're going to have a collection or a list of all of the puzzle pieces that we're going to have inside of our puzzle. I'm going to add a variable, and its type is going to be of BP puzzle piece. So here's my puzzle piece, object reference. I'm going to give it a name of puzzle pieces. I'm going to expose it, and we're going to right click to make it an array. It's going to be a list of them because we might have more than one piece in our puzzle. A one-piece jigsaw puzzle is really easy. You put it down, it's done, success. But a two-piece puzzle, you have to put those pieces both in the right place in order for it to work. So as we do our puzzles, each of our pieces need to be in the correct state in order for the puzzle to be complete. So here's what we're going to do. We're going to create a macro that's going to then check if all of our puzzle pieces are correct. So I'm going to create a new macro, and I'm going to call it check puzzle pieces. All right, so we're going to create a macro to check all of our puzzle pieces. So what we're going to need here is we're going to need some inputs and some outputs. So as normal, we're going to need an input that is going to be kind of where that power goes in. So I guess I can call that input. And where that power goes out, output, so that our macro can run. When we go to run to check all of them, what we're going to want to do is we're going to want to make the assumption that they're all true, right? Because if even one of them is false, if we run into a single false puzzle piece, then our whole thing is false. So we're going to output, we're going to send back whether or not it's true or false. So this one will be a Boolean variable. And this will be the idea of like, is success? Is the puzzle success? For our inputs, we're going to bring in our array of puzzle pieces. So it's going to be of type BP underscore puzzle piece, object reference. And then here, if I want to make this an array, it's a little drop down. So it's a little different than the others where we would right click on it to make it an array. Here we would click on array. And then we're going to do this for each through, checking if it's a success. But if we recalled, when we do this kind of logic that we've talked about where we assume one value, we assume the value that we kind of need all of them to be, right? So that way, if even one of them is incorrect, we can exit and change that value. We need a place to store it. If I create a variable over here on the side, that variable is really going to be part of my object as a whole. I could go ahead and do that. I could make it part of the object as a whole, or I could create what is known as a local variable. A local variable will only exist inside of my macro. When my macro is over, that variable is deleted. It's gone. It does not exist anymore. So if we ever need a variable that is just inside of a macro or just inside of a function, we can create a local variable. So I'm going to go ahead and do that. I'm going to right click and I'm going to create a local Boolean. Now, one unusual thing is I can't really name this Boolean, right? It's just going to be called variable. It's not really named anything. So I'm going to make a comment that names it, right? And so this is my assume all pieces are success, right? It's my assumption about those pieces is what this variable is going to be. So at the beginning, I'm going to come down here and I'm going to assign that variable. So we use set when it's one of our major variables. We use assign when it's this local variable that's going to be deleted. So on input, we're going to assume that this variable is true, right? I'm going to make the assumption that every single one of my puzzle pieces is correct. Then I'm going to search through them. I'm going to look through them one at a time. So here's my for each. I want to break early if I see even one that's wrong. So here's my for each loop with break. What comes in is my array of puzzle pieces. That's what I'm checking. My loop body is what we're going to check. The array is going to give me one of them one at a time. And then when it's completed, when all is said and done, we're going to output. And our success value is going to be whatever value is inside of that local variable. So I'm going to connect it from the same one. So here we go where we assigned it at the beginning to assume that it's true. Then we do our loop, right? What is our loop body going to do? It's going to look at them one at a time. It's going to ask, is it successful? If it is successful, we just move on to the next one. If it's not successful, right, we're going to break. So I'm going to come out of my loop body, and we're just going to do a branch that says, if we are true, so I'm going to look at my array element, and I'm going to get my is success. And I'm going to say, look, if it's true, if it's successful, we don't need to do anything because we're assuming we want them all to be successful. If we are successful, we don't do anything. If we are not successful, what we're going to do is we're going to come down here and we're going to assign this variable again. So let me grab this variable and come down to assign. Only this time we're going to assign saying false, no, right? It is not good, right? There's a problem. Something went wrong. One of our pieces is not correct. So we'll assign it false and we'll come back and break. So these loops that come back, they always look kind of weird to me. I always have trouble figuring out, where do I want to place everything to make it look the prettiest, right? To make it look the nicest. I'm never quite sure, but we'll give it our try here. But what we're going to do is we're going to look through and make sure that our logic is correct. So anytime you build something, don't just build it and rush off, right? Always go back and walk through your code and try to figure out if you did it right. How does it work? So we're receiving as input a start that tells us to go and a list of puzzle pieces. We're going to start by assigning this local Boolean, this assumption variable, to true. So it assumes that they are all successful, that we have them all done correctly. Then we're going to look at them one at a time. What are we doing in that loop body to look at it one at a time? Well, we grab their is success and we check to see, is it successful? Is that success true? If that success is true, we don't have to do anything because we assumed it was true. We're assuming that they're all true. But if it's false, as soon as it's false, we need to set that variable to false and quit looping. We're done. One false is enough. I don't need to look at any more puzzle pieces. You got one of them wrong. When we complete, that value of whether or not it's successful will be true if they were all true. But as soon as one of them is false, it's going to be false. So now we've got the right inputs. We bring in our power. We bring in our list of power puzzle pieces. We've got the right outputs. We've got our power going out, and we've got whether or not we're successful. So always make sure that you build these macros and you kind of think about the options and walk through the code and make sure that you've got it correctly. Awesome. So this is how our puzzle manager is set up with this macro. So I'll go back to my event graph. And what our puzzle manager is going to do is we need our puzzle manager to check for success, right? But we only need really to check for success when we want the puzzle running. Now, in a bigger game, you want to create a trigger box that the tick only runs when you're inside the trigger box. That way you're only checking your puzzle when you're in the room. It doesn't check the puzzle if you're down the hall or if you haven't reached the room yet or if you never go into that room. It's not checking the puzzle. I'm going to go ahead and I'm going to check those puzzle pieces on every tick. It is not the efficient way to do it. It is not the way you would do it in a major project. We've already gone over how to turn our tick on and off so that we only tick at the right times. We did that with our view trigger that checked whether or not we were looking at an object. So I'm going to come off the event tick and I'm just going to say every frame, right? We're just going to call that macro, right? Check puzzle pieces. I'm going to bring in my list of puzzle pieces. That's the puzzle pieces we're checking. If it is successful, if we did succeed, right, when we come off of our output, we're going to call a new event. So I'm going to create a custom event for victory. We're going to branch off of this output. If the branch is true, if we were successful, right, and we did it, we want to call victory. And then I'm going to make sure that I only do victory once. I don't want to do victory over and over and over again. I just want to do it once when we've completed the puzzle. So here we go. Every tick, I'm just checking my puzzle pieces. I'm going to do a branch. If all my puzzle pieces were true, then just once. We're only going to be able to do this once. We're going to, set our victory, and we're going to call our victory. My victory, I'm going to go ahead and add another variable here. This is my interact mesh, right? And so this is my victory interaction. Activate that. My type is BP interactable mesh. I want an object reference, and I could have an array of them, right? Let's go ahead and do that. We'll go ahead and we'll have a bunch of them. So if I want to have a bunch of exploding gnomes, I can put a bunch of exploding gnomes in here. So we'll grab that victory interaction array, and then we're just going to do a for each. And we're just going to say, look, here we go. For every single one of those, right? Every single one of those gnomes will come off our array element, and we'll just tell it to interact. Right? Actor start interact. There we go. That's telling all my gnomes to explode. I could put a door in there, make that a child of BP interactable mesh. If my door was not a door, if it was an interactable mesh, I could open a door that way. So using those child classes, we can do some interesting stuff. So this is going to give us the ability that we're just going to do multiple things on our victory. I can save, I can compile. And so now I've got this idea that inside of the world, here's that BP puzzle manager. If I take this off and I go to my default, here's the list of puzzle pieces. Right now, there's none. There's no puzzle pieces. But if they're all victorious, if there's no fails, right, it's going to do all of these interactions. So I'm going to go ahead and, oh, my exploding gnome needs more hookup. So I'll just put my one exploding gnome in there. So here's my puzzle manager. Right? I'm going to add one object under my default to my victory interaction. Choose that. There's my exploding gnome. And so now when I start, he should explode right away because of the idea that I don't have any puzzle pieces. So if I have no puzzle pieces, it's going to assume they're all victorious. Boom, he just exploded as soon as we started. So I know that my victory condition works. It checks all the puzzle pieces. But right now I don't have any. There are no puzzle pieces. So I need to make those puzzle pieces. In our next video, we'll take a look at building those puzzle pieces so that we can actually start to integrate our puzzle.